Which one was the other one? The one like...
The other one was the one with the 4 charges in a square.
Oh yeah, that one was so dumb to me because like
I did not understand that one. I just kind of wrote down whatever, but I actually got surprisingly close to the correct answer. I was so shocked.
I thought it was like 0. I was like, okay, so I guess it's 0 because I added them all together and it was like 0, and I was like, okay, whatever.
Well, it would be 0 if there were equal charges.
On
If they
all
were
four,
all
the
just
same
Q.
direction. I was looking at magnitude only. I didn't look at direction. So I was like, because technically it would have, I was like, but I didn't do that. So I was like, whatever.
Yeah, that one was confusing. I did find like a website that explained it pretty well.
Okay, wait. Can you explain that one then? Because I understand. I would understand it if the answer was like it either goes in positive Y or negative Y, but I don't know why it's only positive Y.
Okay, yeah. Let me pull it up and then I'll share my screen.
Yeah, I did so bad on that quiz. That quiz is gonna kill me. Oh my god.
I don't think I've ever gotten an A on a physics quiz. I always end up getting a B no matter how hard I try.
I think on like the first, like on the review units, I got a B, I think. Or on, I might have gotten an A. I think I got like 1A because those were pretty easy, but the other ones I was doing awful on. This one made me upset. I got the wrong answer. I thought it was A.
I thought this one, yeah, I really thought I would get this one right. And then, I mean, I understand later when she told us the correct answer, I was like, oh, okay.
That makes sense, I guess, but like, not really. What? Yeah, it is.
Okay, which one?
This
okay,
one.
let's go for this one first. Okay, for this one, I actually just, I drew pictures for all of them. It was a lot easier to understand that way. So I don't know if I can annotate that.
Okay. I think part of it is that I just don't understand what it means. It's like, does that mean like like what does at the origin mean? Does it mean like something was just put there or what?
Okay, so basically there's like an X and a, just imagine like this is an X and a Y axis and this is the origin right here. Mm-hmm. Right? Okay. And then this is Q2, which is at 0.5. Mm-hmm. Right? And this is Q1, which is at negative 0.5. So they're equidistant from the origin. Okay. Yeah. And then for the first one, it says, determine the overall direction of the E field. And they're both, it says they're both positive, right? So the E field.
Oh, so the equal distance makes it. Oh, never mind. I don't get it because it says a negative x-axis. So
yeah. So basically, since they're both positive, the E field is going to go away from them, right? Like it's going to travel away from them because, you know, like it always points towards the negative.
Okay, yeah, the direction would go opposite because they're both positive. So one of the, but wouldn't that mean like only one of the, well, it's an overall, but I think I get that the one at like the negative 0.51 will go negative, but how does the positive 0.51 point positive?
Oh wait, hold on. So it says Q2 has twice the charge, right? So this is like, let's just say this is 2Q and this is Q. So now we're saying for A, it says at the origin, right? Let's just start with the first one. So this is at the origin. What is the E field? So the E field going away from 2Q is like really big, right? Because 2Q is a bigger charge. Whereas going away from Q is about half that size.
Oh, okay.
Yeah, so you see how that cancels out? This one is the bigger one. So in the end, it would go along, so A is choice 3, right? Which is along the negative x-axis because it's going this way.
Okay, that makes sense. So then at x equals 0 and y is a negative number, it would be...
So try the second one, right? Okay. X.
Let me draw a picture. Yeah.
Yeah, I think drawing was what really helped me. I had pictures of all of them.
Okay, so when x is 0 and y is like a negative number.
So that'd be somewhere. I just make a fake point. Like I just said like it would be down here.
So the electric field down there, they would still bounce away, right?
Yeah.
Okay. And of course, Q is going to be bigger. So yeah, it would be. Oh my God, what was I talking about? Anyway, yeah. So so would we do like the net force here or?
I don't know. You kind of just eyeball it. So whichever direction the force ends up going in, it's gonna be like the bigger force obviously is the bigger influencer, right? So for this one, it would kind of end up going like in that direction.
Yeah, which
like
is
in that
between.
direction, which is choice 7, where it says between like, so this is like 180 over here, right?
Yeah.
And then down here, that's 270. This took me a second to understand the degrees. I was like, what is this talking about? But and I realized it was like the
a coordinate plan. Oh, that makes, I feel so stupid now. Okay. You know what?
It just takes a second to understand.
Okay. And then wait, so why does the direction go towards Q? Like why is Q so big now? Hold on. Let me be smart. Yeah, okay, I get it. I'm just dumb right now, but I get it.
Okay. Do you want to finish going through all of them?
Yeah, okay. So when x is negative 0.5, which is what Q is, right? And
yeah, so that would be up there.
So Q still goes in.
What happened?
I don't know. Well, I do know that at that point, yeah, 2Q would still push out, right?
Yeah, it would be going that way.
And then that Q would just be like
straight up.
There. Yeah.
So it would be going like over here, right?
Which is between 90 and 180, right?
Yeah, exactly.
So 6.
So between right
oh
here.
my God, I got it for
6.
real. Oh my God.
Yeah. Yeah, it makes sense. I think just drawing it out is what made it make sense, at least for me.
It's their force on each other, which is like, I know that kind of.
Yep. Okay, so should we go to the next one?
Yeah, we can skip this question now.
Okay, let me get this out of here. Hey Maham and Hiba, we're just kind of going over like whichever questions you guys want to do, not just on the quiz. So right now this is on the quiz, right? But we can go over any of the ones from the homework as well. I'm just kind of like whatever you guys want to go over, I'll just go over that. I didn't really plan anything specific.
Okay, I don't really have any problems on the homework that I like necessarily like remember having a hard time on. So I guess we can, like, do you guys have any questions you guys have a hard time on the homework?
Not really. I ended up I did have a few of them. They were a little bit confusing. We can go over those, but I figured all of them out before the quiz on Monday.
Okay. Have y'all done question 5 already? Because I feel like the way I did it was I got the right answer, but I feel like the way I did it was weird. So how did you do it?
We were just about to start that.
Okay, cool.
Okay, so for this one, hold on. Okay, I actually found a really good website. Let me pull it up. There was this website that explained it really well. Here it is.
I'm probably gonna like watch the organic chemistry tutor the day before, or like over the weekend, so that on Monday or I guess on Tuesday I'll be ready for class. Because
what was I gonna say? Oh yeah. The videos I sent and the Slack were really helpful. Also, the Khan Academy AP like electrostatics, like that whole lesson was like really helpful too. In case you guys just like want to watch those.
Okay, I looked at the Khan Academy thing for current because I didn't realize that wasn't going to be on the quiz. But it didn't really make much sense to me. It was mostly just confusing. But yeah, I'll try to watch those.
Yeah, videos. and the 2 videos I sent in the chat, if you watch, was like I don't know if they help you guys, but like they like helped me a lot. And the Khan Academy ones, like the entire like electrostatic lesson, like I started from the first video, just went to like the last one, and they were all pretty good. So
okay, can you send like the series in the Slack and we can so everyone
okay,
can.
yeah, sure, I'll do it right now.
Okay, so this is actually I found this afterwards. I tried Googling the problem and it has it has the other FRQ as well if you want like another explanation. But so the last one, it even says like it's hard. And this one, honestly, I didn't know what I was doing while I was doing it. Okay. So it says that you need to kind of like, you need to find out all of the E fields of like each of them. And then you need to kind of like see like which parts cancel out and which ones add up. So it says the distance to the center for all of them, it's half of diagonal, right? So it'd be L, and then L squared of 2. And if you take the half of that, you do some algebra and it comes out to L over square root of 2. I can show you how the algebra is if you want to see it.
Yeah, I know math, Pythagorean theorem.
Yeah, okay. Where were we? Okay, so then they just use like the formula KQ over R squared. And then you put in, you know, L over square root of 2 for R, and then you put in just Q for this one, right? Actually, I think it starts with the lower left, so it would be negative Q for this one. I think they just went with the magnitude. Yeah, it says with the magnitude. So if you multiply it out and you like, you know, do some more algebra, you get 2KQ over L squared. And you do that for each of them. And then for the ones with 2Q, it's 4KQ over L squared. And then what they did is that they put the angles. I didn't really understand the angles. To be honest, I just kind of like pointed them. I don't know. Honestly, I have no clue how I got this, but the angles were confusing to me. And I also didn't understand how the X components canceled out. It says the X components cancel out. But yeah, if anyone wants to try to explain that, that would be good.
I'm sorry, I was sending the Khan Academy stuff. What were you asking?
So it says after we get all of the E fields, I'm kind of confused about how they got the angles, or I kind of understood the angles part of it, but it says here that the X components cancel out when you put all the arrows together, and that was really confusing for me.
The X components cancel out. Okay, so I think because
Well, let me just draw in the arrows. I think all of them were pointing out. They were all just pointing out.
Yeah, there's 2 arrows like pointing, like one pointing like north to the right, and then up to the right, and the second one's pointing up to the left. Yeah. I think no, but I was saying the resultant vector is just like what it looks like is just one like arrow pulling up to the north. Or no. Wait.
Yeah, no, it says in the positive Y direction right here.
Yeah.
But I don't understand how the X components cancel out, because even here, oh wait, like I understand this would go up because these two are attracted, but then for this one, wouldn't it be going down? So for that one, the Y component doesn't point up, it points down.
But what if they cancel out? Oh, I don't know. I don't know.
Yeah, I didn't see that they canceled out. I literally just like found the resultant 2 vectors and then just found the angle in between, or just found the line like from the tip to the tail of the second one. I don't know why the X components cancel out.
What's the first and the second one? What do you mean by that?
Huh? Oh, wait. Cause you know, like if you look at the picture, like where can you go up a little bit?
Yeah. Oh no. Yes.
My legs.
Also, I think you can draw on the screen if you want to, Mahan.
Yeah, okay. Let me just see like what I even, because I don't remember canceling the X components out, but I remember like,
well, if you did tip to tail and then you added them, then they probably canceled out like automatically, I guess.
I'm trying to remember like even like what, I'm so sorry, but okay, because it's asking for and I got it later too. I didn't even get it like when I was taking the quiz because I didn't do that question. I did the second one instead. Okay, yeah, because so like I just like kind of like drew like the charges, right? And then I was like, if there it says there is E field in both magnitude directions center of the square. Okay, so if there's like a positive chest charge in the middle of the square, then you have like the 2q, the plus 2q, like pushing it
Over
pushing
L.
it up, and then one, yeah, and then the
Wait,
so
wait,
then
wait. Where is the positive 2q pushing?
here I'm so sorry. I was like, okay, I'll try and draw on it. Can I do that?
Yeah, I think you can. It should say intake.
Where even? I don't know how to draw on it.
It should be at the top bar. I'm not really sure.
It's
It should be somewhere.
mm,
There should be a little
oh, and
drop down.
okay.
Yeah.
Yeah.
Okay.
So okay. Okay. So if you have like a test, a positive test charge in the middle, right?
Mhm.
Then oh my god. Okay, that's so bad. Okay, so you have the plus 2q that's pushing it up, right? With that's or like that's pushing it up. Sorry, that's like pushing it up like this much, right? Right?
Yeah.
And then you have this plus q that's pushing it away like half as much, right? Like it's pushing away with like half as much.
Yeah.
So then I got the resultant vector was just like
That's why.
just
Okay,
like
yeah.
like it was
Yeah, no, I get it. I get it now.
and the
I
same
kept
thing. And then
kept-
there was
I kept looking at all of them as equal instead of like
Mhm.
that one is like bigger, so that's why it cancels out. Yeah, that makes sense.
how do
I
I
think one thing that confused me was like the. Oh, sorry.
I just want to say, Maham, I think you're breaking up if you're trying to say something. But yeah, CJ, go ahead.
I was gonna say one thing that confused me was like the idea of like the center charge, and I was like, is it positive or negative? Like, how do I treat it?
It's positive. It's looking for electric field, and so electric field is just like it's the so like if there was a positive chest charge, like what would the effect of each of these charges, like what would it have on all, I mean, what would it have on that positive test charge?
Oh, so that's why like when we do E, it's just E equals K Q over R squared because like the other Q is 1 basically.
Yeah, and actually, okay. So actually, electric field is different from electrostatic force. Electric field is newtons per coulomb, and electrostatic force is just newtons.
Okay.
I actually didn't even look at it as a. I didn't look at it as a test charge in the middle. I just thought, okay, so you know how these two are both positive? That's why I figured that this one, the 2q, like we said, it would go that way. That would be the 2q charge because it's sorry, no, that would be, hold on.
Because
Yeah, no,
charge.
that would be q's charge, right? And then the 2q1 would be even bigger than that. But then I wouldn't be pointing down. Hold on, I'm confused.
Physics is hard for me.
Yeah, physics. Physics is not fun.
I like the easy ones where you can just plug in the numbers. I can do that.
Yeah, the rest of the problems are actually like pretty chill. That's why I was surprised by this one. This one was really hard. Yeah, no, I still don't get it because I thought these two, this Q and 2Q would repel. So then wouldn't the
because if it's a positive test charge, then Q would go into it, bump into it, and go the other way.
But do we always have to? Do we have to assume that there's a test charge for electric fields? Because that's not what I've been doing.
That's the way that I guess not. But I guess CJ, just so you know, like it's KQ over R squared, not because the first Q is the test charge, but because you're measuring it in newtons coulomb, newtons per coulomb, which means you're doing kqr squared times 1 over q. So the
Other Q's canceled out.
Yeah,
right?
the two q's cancel out, so you just have kq over r squared.
Okay.
I mean, she was thinking of it like as a positive, because if you look at the way on her answers, the way that she like drew a vector, like one going like, yeah, see. So she was thinking of it the way that I was thinking of it.
Yeah.
Where if it's a positive test charge, and then
Like a little center, and so you have your main because you have the two repelling forces, right? One is pushing it like up to 1/4, one's pushing it, or sorry, one's pushing it up with the 2q, and then another one is pushing it down with the 1q, right? And so the one that has like the one that's going to have more a higher electric field or electrostatic force is going to be the 2q, which is why like you see that first vector.
Even if there was a positive test charge in the middle, why is the 2q going like in this direction? Wouldn't it go away like in this direction?
Well, okay, so like, okay, let me try and draw on it again. Okay, why is this like the hardest thing I've ever done in my life? Okay, so I don't know like exactly what she was talking about right here, but let's say like there was a charge in the middle, you know? So then you have like the 2q that's repelling it, right? Okay, yeah, see? So you have this 2q that's repelling it. This is the 2q that's repelling it. Then you have the 1q that's repelling it right here. And so your resultant vector is going to be this right here.
So it's the effect on the test charge, not.
That's the way she looked at it. That's
Okay,
after
okay.
when that's
But then-
that's the conclusion. I mean, I
But
could be
then
wrong, but
for
that
the
makes sense.
for the negative, shouldn't it be the other way? Shouldn't they be
Yeah, it would
being
be-
like attracted?
Well,
Yeah,
it's because it's attractive force. So it doesn't actually matter how you draw it, but people, so like, okay, so do you remember like whenever we like look at the triangles, dear God, that's horrible. Whenever we look at the triangles, whenever you have like, let's say you have a positive Q here and you're trying to see like the force on the other positive Q or whatever. And you know how we like draw the vector outwards and instead of drawing it like this from here, you tend to draw it on the opposite side to kind of give it perspective that it's being pushed out. Do you kind of get what I'm saying? Like instead of, so let's say like you're asking for the effect of this Q on this Q.
Okay, no. I understand that. So you're saying that this arrow is the one on negative Q.
Yeah, but whereas negative charge, so if let's say there's a negative Q right here, then the force of the negative Q on this Q, you would draw it like this. Not protruding out of the diagram, which is why you have the test charge here. You have a negative 2q force pulling it up like this, and a negative q force pushing it down like this, and then the resultant is going to be this right here. I'm so bad at explaining, but do you?
Yeah, no. I got it. I just realized the arrow is not the effect of the test charge on the red circles, but it's the effect of the red circle on the test charge.
Yeah, exactly.
So negative 2q is actually pulling the test charge. It's not that this one is pushing it away.
Oh, what is
yeah. Yeah, it's doing it. Yeah, it's doing it to the test. Because isn't that what like electric field is? Like it's what it does to the test charge.
Yeah, exactly. Yeah. Wow, that took a while to understand. Okay, do we all
She's not here,
get
I'm
it?
really crying.
Do we all get it now? Is there anything else?
I'm assuming I get it at this point. Also, make sure, can you put the link that you use in the chat just in case I need to look back at it?
This one?
Yeah.
Actually,
I don't quite understand what they were doing actually. Like that looked like it took forever.
Oh my God. It all looks like it takes forever.
Maham, your explanation was a lot better than the one on the website.
That makes me angry.
I feel right though.
And then I wasn't able to take notes during class. She was going so fast. So I'm just gonna have to I took some screenshots. I'll do that later.
She was going so fast, and then my internet cut out for like 5 minutes in the middle, and I came back and I was like, I have no idea where we are, what we're doing.
I only have the word, like, okay, I have some standard definitions, and there's like electric current symbol I. Then she like switched slides to talk about something else for a second. She went, and I thought she was gonna go back, and she just went to electric resistance. So like I just have like a empty space for actual currents. But whatever.
Didn't we learn about actual currents last time in 5.1?
You know, there was questions like related to currents on the homework, but we didn't actually learn it yet, which is kind of weird.
Yeah.
I didn't see any questions about the current on the homework.
Were there not? No, they were related to what's it called? You know, like a capacitors, like batteries.
Oh
like
yeah,
the volt
which
thing.
I didn't understand that one at all. I just kind of memorized the information in it in case that we needed it for the quiz. But I didn't.
Yeah, Emily explained it to me, but it was the explanation was very like
weird, like going in the circle. Like I
actually once you learn the first 2 slides of the current 5.2, they actually made sense. But basically it was just like it's just where the electrons were moving. So the electrons are going to move like towards a more positive charge, right? So they're just moving in circles.
Mm-hmm.
And then they eventually reach like equilibrium, I think. Which is why like an uncharged capacitor and a charged capacitor, they both have a net force of 0.
I only have myself to blame. The best test I've done in this class on an actual physics unit was like an 83, and I got that because I watched the organic chemistry tutor. But this time I got lazy and I didn't, and this is what's happening to me now.
I'm really glad I made myself do the practice questions for the quiz, because I usually like kind of just like get lazy and don't really do them, but this time it actually really helped to do all the practice problems. Okay, so are there any other questions like on the quiz? Anything else we need to go over on the quiz, or we can move on to the questions, or if there's nothing else, I mean, we can just end it here if you guys don't have any questions.
Do you want to look at it? Because I don't remember anything that I like didn't understand at all.
Yeah.
But there might have been something. I just not specific.
Yeah, we can just like scroll through them real quick maybe and see if anything, or you can just take a second to check your work, because I know I usually like mark the ones that I didn't understand. So if you want to just
so do I remember one of them I didn't understand was in the I think the first one of the positive, or not positive, potential energy, I think was like number 15. No, I know that now. 15? Okay. Number 19. I know 15 now. That was where I was dumb. I think it's 19.
19? Okay.
Yeah, I know I think I get it now, but I didn't get it before. It was very confusing for me at the time.
Okay. How much work is required?
No. Now now I know it, guys. Now I know, but before I didn't.
Yeah, I think you would just use I think it's work equals like change in velocity times something. I don't remember. I don't have my equation sheet with me right now.
According to this, this might be a different question. I don't care. But yeah, yeah, I got it. I got it. I remember. I asked Em for help.
Okay. So we can. Anything else
I think
that you wanted to go over?
All this pretty much made sense to me. CJ, do you remember the trauma that one question gave us?
Wait, which one?
Actually, go up a little bit. This question, it gave us like all the world's trauma, because you could, if you wanted to find theta, you had to do it in radians, because if you tried to find theta in degrees, you wouldn't get the right answer.
And I was so confused. I'm still
you don't have to do any of that. You just use 3 meters. That's it.
That's what I did. And I got the answer. Everyone was like, no, you have to do 3 points. And I was like, but I think it's just
you can't, because moving from like say like, can you guys see the little hand like cursor thing?
Mm-hmm.
Yeah, so like say if you go from like right here to B, you don't gain or lose any potential energy because you're not going with the electric field. So you only gain or lose potential energy for going in the same direction.
Oh, so it goes with the electric field. Okay.
Yeah, so
Yeah,
it's
and also
only in
if you
straight
go up,
lines.
you're not doing any work. Like if you go upwards, you're not doing any work, right? Because that's cosine of 90.
Oh yeah.
Yeah, that too. Yeah, so you don't do any work if you go like you only do work if you go straight with the field or straight against the field, but not if you go
I-
like any like you
What
know.
I thought it
go
what I thought
straight
it was
to-
doing is I thought it was going across 3.6. And like I mean technically it was right with radians, but I don't even want to go into that because I don't understand that. I don't
Yeah,
want
no,
to understand
it's a lot easier. Just use it. Either it's going with or against, and if it's going at any weird angle, then calculate the x component.
that. Okay.
Yeah. I wish you'd have told us that in class. It was kind of annoying to figure it out by myself, but
X components in general, I wish he had taught because I learned that from like the organic chemistry tutor. I was like, what is an X component?
yeah.
Yeah,
We did
so
some of that in pre-cal last year.
question.
Mhm.
This is what I was asking Shruti or whoever I was with in the room. And I think like none of us could really understand. Whenever you're looking for work, it's just the horizontal. You're just looking for horizontal work, right?
What do you mean by
Like I mean,
horizontal?
you're just sorry, not horizontal work. You're just when you're doing QED cosine theta, your D is going to be the horizontal direction, right?
Yeah. It's the direction like we said, either with the electric field or against the electric field. You don't do whatever is like side to side, like here, like the from B to like here. That doesn't count.
Okay, that's good. Okay, thank you for telling me that.
Okay. Oh my god. I hope I don't fail. Wait. That's my main concern at this point.
Yep. Is she gonna post any more practice problems, or is this like all of it?
I think this is gonna be it. She's not gonna post anything else.
Okay.
I think she just underestimated this unit.
She went really fast though. I feel like she went really fast. I mean, like
She did.
I
go
was still
pretty
able to like
fast.
pull it together, but it was kind of hard.
Watching videos help me. MG and watching videos help me more than anything.
That's true. MG helped me understand like some parts that are very important to understand, like high to low, low to high.
Yeah. That
Yeah,
that whole concept reminded me of osmosis basically, and things always move to lower concentrations from higher concentrations without energy. Okay, well, if there's nothing else, we can end it here. And if you guys have any more questions, you can just ask on Slack or you can text me.
Okay.
Okay, thanks for coming, guys.